Okay. Hello, my name is Matthew Winstone, and I'm here to talk about Drupal on Kubernetes. Resume the timer, speaker notes. Next slide. No, that's bigger slide. Next slide. Blank slide. That's not supposed to be blank slide. About the template. There we go. All right. Oh, so for anybody who wasn't here earlier, I finished these slides at lunchtime. So if there's stuff missing or in the wrong order like that, it's just I haven't had time to clean it up. I was more worried about the demo actually working. So I'll post the slides, the link to them when they're actually ready for external consumption. Anyways, my name is Matthew Winstone. I'm the CEO and co-founder of Coldfront Labs. I've been doing Drupal stuff for about 12 years now. I actually started working here at Ottawa U, and then went off and founded Coldfront, and then been building Drupal on various infrastructures for quite some time. My experience is mostly dealing with actual VMs with Puppet and configuration management that way, with some dynamic provisioning through normal VM APIs. But recently, been playing a lot with Kubernetes because that is the hot word of the year now, because everything has to go Kubernetes for various reasons. And so I'm here to just talk about what Kubernetes is first off, and then show how you can actually run Drupal on Kubernetes, some of the existing solutions out there, and then why my method is a little bit different and maybe a little bit better. I don't know. We'll find out. But for anybody here who doesn't know what Kubernetes is, I Googled what is Kubernetes, and this is what popped up. So it's an open source platform that Google created. I think they originally called it Borg or something like that, but then they renamed it because of Paramount. For running containers across multiple clusters of servers, and it's pronounced Kubernetes, some sort of ship. And I guess another important concept for this talk is the concept of containers. So here's familiar with what containers are. Raise a hand. Docker. Has anybody heard of containers? Yes? Okay, it's like a mini VM binary for an application kind of deal, without the actual OS part. So, okay. All right. So we're going to cover what is an actual Kubernetes cluster, or at least the important bits for this presentation. This is not going to be a cover everything, you'll be an expert in Kubernetes at the end of this, because to be fair, I'm not an expert in Kubernetes yet. But this will cover all of the important parts for getting Drupal up and running. So clusters are made up primarily of nodes, pods, and namespaces. So nodes, for those in the Drupalverse, have yet another meaning. So nodes are pretty much the actual servers that are running things. So that they actually run the executables, that they're running the actual containers. The pods themselves are basically just the containers. The pods are the containers that exist somewhere on a node. And the namespaces are the groups of pods running within the nodes. And because after I made this slide, I realized that was confusing, I made a diagram. So that's the cloud, that's your cluster. And then this red bit is the namespace that your pods belong to, and each one of these things is an actual pod. So you have a cluster, your application usually exists within its own namespace, so you have all the resources specific to that namespace. Your service accounts and access controls are usually namespace specific. And so that is the little chunk of your little cloud that your application exists in. And then everything outside of that is just other stuff running in the cluster. They could be cluster level resources, or they could be their own namespace running their own thing. And that's why the whole concept of Kubernetes and using cloud containers like this is so enticing, is because you have all of this, all of these resources available in this cloud section, and you get to fill up as much of it as you can with different things running, as if they were running with on their own machine. But you can borrow resources when one thing is not busy, or another thing becomes extra busy. You can borrow more resources from it. So it's a way to really optimize, if you have a large infrastructure or even just a small infrastructure, really optimize how you can break out the work between things. Okay, another important concept. Role-based access control, RBAC. So if you look up anything Kubernetes on the internet, you're going to see all sorts of people telling you, you need to use RBAC. RBAC is a thing. RBAC. It took me probably about a week to be like, you know what the hell is RBAC? And then that's when I actually looked it up. So basically role-based access control. There are two kinds of roles that can exist within a cluster. So you have a basic role that is namespace specific. So you have a role within that little red square. Then you can have cluster level roles, which allow you to do things essentially cluster wide. But they also sort of tie into namespaces. It's a little confusing, but this is essentially how I keep it organized in my brain. So we have roles where you just define this role can do these things. And the things that you define the role to do are essentially access to certain Kubernetes APIs. So you'll have APIs to create resources. You can have access to like delete resources or just list them if you're just writing a monitoring role, that sort of thing. And I'll show you what the roles look like once we get to the YAML files. Role binding is just the link between a role and an account, a service account in your cluster. So, and then cluster roles is the same deal, except these permissions are for cluster-wide resources, and then you have a cluster-wide binding for stuff. So, any questions so far? Because all this stuff, it's a little important, because otherwise my demo's not going to make any sense. Everybody's good? All right. If you get lost, I don't blame myself. So, all right, Helm. That is another very important thing when you're talking about dealing with Kubernetes. So Helm is trying to be the package manager for Kubernetes. So it generates and defines your deployments and resources and disk space and all that stuff that you need to actually deploy something to the cloud. But you can do so the theory being that someone creates the Helm chart for you. You put in just the YAML values you actually care about to actually deploy your app, and then the application appears somewhere over here magically. Once you see the sheer number and amount of YAML templates and files and stuff that get generated, you'll understand why Helm is super important if you really want to deal with Helm templates versus just writing the YAML by hand. The important bit being makes installing services and applications easier. It's supposed to make it easier. Sometimes Helm can be kind of a pain in the butt, and there's some issues with Helm and Tiller and versions of Helm and all that kind of stuff. So we'll get into that. Okay, so now we get into a little bit more of the what exists already as far as Drupal and Kubernetes. So I guess the most well-known install would be the stable/Drupal Helm chart. So this is provided by Bitnami. It looks like they essentially just maintain that whole stable repo that everybody in Kubernetes uses to actually install apps. So they have charts for MariaDB, they have charts for Nginx, they have charts for Apache, and they have a chart for Drupal. So the chart is very well written. They definitely know Kubernetes. I'll give them that. But the chart does have some limitations. So the biggest one being this chart only lets you run Drupal as a single pod. There's no replication or scaling available to it, just because that's how they wrote it. They also, it does manage the database for you, so it'll deploy like a MariaDB instance for you and then link the two up together. But they're missing a lot of stuff when it comes to the Drupal side. So I get the feeling that they really know Kubernetes, but they don't really know Drupal or the stuff that you actually need to run Drupal at scale. So they let you store the database using password, but it doesn't let you set like the Drupal hash salt for example. It doesn't handle running cron. It doesn't do replicated shared disks so that you can actually have multiple pods running. I think that's their main reason for not supporting replicas. But I learned a ton just looking at this chart that they follow the Helm guidelines. They use all of the tricks in there. So I definitely recommend at least reading the code if you want to learn about how to write a Helm chart and start understanding how Kubernetes works. Yeah. Next one, we have Drupal WXT Helm Drupal. Yeah. So this is written by Will and Zach at StatsCan. They use this to run their infrastructure. it's pretty good. I have some, so I guess some architectural like disagreements with how this thing is set up. Mostly it's just, it seems very complicated for what it does. And I think it's a little too specific to be able to use like outside of StatsCan. Although, you can prove me wrong. But it is designed specifically to run Drupal WXT. It comes with that distro built in, and then it deploys your application. So it does it. I think it uses S3 for the storage, so it can do replicas, which is good. It has PHP in its own container. I think the web server in its own container, and then Drupal over here too. So it's very, very broken down into the like whole microservice kind of thing. But since Drupal's not really a cloud native application, if we're gonna use throw around some buzzwords, I don't think that's quite necessary to be able to run things that way. So anyways, I also learned some stuff from here. I learned that S3 is annoying, and yeah, it gave me I guess the goal of trying to make a simpler chart. So I like the simplicity of Bitnami, but I didn't like being limited by it. And I saw what you could do with a very exhaustive and very elaborate chart, but it was too complicated to really use on a regular basis. So I wanted to find something sort of happy in the middle, which got me thinking. So 4 months ago, I decided I'm going to present Drupal Kubernetes, and I have no idea how Kubernetes works. Didn't even know, I couldn't have filled in those slides 4 months ago. So I was like, okay, so if I want to do this on Kubernetes, what do I need to actually run Drupal? So I need PHP, that's obvious. I need a web server, I need a database, and I need files. So you need your public and private files directories. So I wanted to set up a Helm chart that will do this for me. So how do I want to meet my requirements? Well, the first three were pretty simple. You have PHP FPM, which you could run, like I said, I learned from the WXT one. You can run it separately, or you could run it within the same container as Drupal. I knew I wanted to use Apache because I know how to use Apache. And MariaDB, for the databases. So I looked at these 3 points, and I decided that MariaDB, I could swap out MariaDB with MySQL if I wanted to, or I could swap it out for Percona or whatever, and I don't have to change anything about Drupal itself. So I decided that MariaDB would fall outside of the scope of my Helm chart. So if you want to deploy a database cluster of some kind using on Kubernetes, you can do that. You can still have it in your same values.yaml file, but my chart is not going to take care of doing that for you. You just use MariaDB over there. PHP and Apache, though, those ones, if you change a version of PHP or if you swap Apache for Nginx, you have to make a change to Drupal, because you need to either swap out your htaccess for something, you need to update code and stuff to go from PHP 5.6 to 7, whatever. If you're still running 5.6, you really shouldn't be, by the way. Or if you want to go from 7.1 to 7.3, or if I wanted to change, upgrade a version of Drupal, which has to change the htaccess file, that has an effect on Apache, so you might have to change some settings there. So I decided that the thing that contains the entire application, my Drupal binary, is a PHP, Apache, and Drupal is all together in one container. And then that way I can deploy them all together in one shot and test them all together, which is the important bit. Okay, so I created a container. So this is where all the Docker stuff sort of comes in. So I based it off of, so when I start getting into using links here, where is my cursor going this way? Too far. Web DevOps, PHP, Apache. So this is the base container that I actually chose to go with, mostly because it's, one, really well documented. It has all of the PHP and Apache bits all together. I can control every aspect of PHP and Apache using environment variables. I can use it for local development. I can use it on the cloud. It is a great base container. So this is what I picked as my base, and then I added on the parts just for the Kubernetes environment management and that kind of stuff, which I'll show in a sec. So first lesson was go see what's already been done, well and then borrow it. So, there. Oh, I fully plan to make all these like containers and the actual Helm chart like public. Once again, I finished the demo yesterday, and so I need to clean it up so that it's presentable to people. So it will be available for everybody else to use. Okay, so next part. So I had my container. I knew how to get Drupal onto the container. I had all my files organized. Drupal would actually run on the container. All right. So next up was actually writing the Helm chart. So this is when I was like, okay, the WXT one is too specific. So let's see if I can just use the Bitnami Drupal one with the container that I want to use, because they do offer you quite a few options as far as controlling where it's looking for stuff. But then when I started diving into the details of it, I noticed like those things I mentioned, like it doesn't manage cron, doesn't handle multiple replicas, it doesn't do all this kind of stuff. So I, heavily inspired by stable Drupal from Bitnami, and I plan to open source this one, or even see if I can get the stuff committed into it so that it's still the one everyone uses. I just don't know how they handle, breaking changes and that sort of stuff. So yeah, and that's mainly what I'm going to show off in a second. But the biggest thing was if I wanted to get replicas to scale up, I needed to have Drupal's private and public files shared across multiple pods. And that was the most complicated, most pain in the something that I had to deal with. Mostly because a lot of the cloud providers, other than like an S3 container or an S3 object store somewhere, they don't have, I guess, cloud native. I know I roll my eyes every time I say that. It was just because I've been reading a lot of blog posts about cloud native things, and it's just like, ugh. But anyways, they don't have a lot of cloud native storage options. There's a new spec that's been, there's a computing storage or cloud storage interface is like a new thing that Kubernetes sort of announced a couple months ago that it's supposed to solve the problem of like one pod being able to write to, or multiple pods being able to write to one place at the same time. But right now, each pod basically has their own files by default, and then you have to take care of making sure that they're in sync. I didn't want to do that. I wanted it to actually scale up properly. So NFS, good old NFS. So I decided that I would use the NFS server provisioner Helm chart, which also Bitnami wrote, so good for them, which, as I found out 2 days ago, deprecated. Yay, in favor of those CSI plugins. So once these CSI plugins get like stabilized and they're actually supported by most of the cloud cloud providers, I'll probably swap that in the chart. But for now, NFS works. So we're going to use NFS to be able to have multiple pods writing to the same disk for both your Drupal files. Yeah. All right. Helm 101. Been rambling for 20 minutes about Helm. Where's my mouse? There it is. So, this is Helm, sort of. Here's my mouse again. Where is my example? Initialize Helm. Okay, so Helm actually comes in two parts. So Helm is the worker that's doing your deployments for you in Kubernetes. So you have Helm, which is the local, I guess, sort of binary tool that you have, and it has something on the other end called Tiller. And Tiller is responsible for taking the stuff that Helm generates and then deploying it to the cloud. And your Tiller, like service running in that cloud, is a service account that has a cluster role binding that gives, basically you have to give it administrator access. The version 3 of Helm, they realize that's a big security problem because that means if anybody can talk to Tiller, anybody can do anything you want to the cluster, like destroy things. And so they try to mitigate that in the current version of Helm, but the version 3 of Helm, they're actually ditching the Tiller part, and you're just going to have the local thing just push your stuff directly to your cluster. So it's like the local user's access that will actually check to see if they're allowed to do things on the cluster. So, but anyways, I'm rambling again. So Helm is the tool that you have to have installed locally to actually do things. So Helm deals with repos. So the default repo is some Google Cloud, something or other, somewhere that it comes, it's already there. You just do like Helm install stable/Drupal, and it'll do it because it already comes with that repo pre-configured. And then blah, 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 blah. And then, yeah, and then Helm generates what are called releases, which you can actually list your releases to keep track of like what you've deployed, what version it is, when it was deployed, how long it took to deploy, that sort of thing. It's also how you remove things. So if you're just like deploying a temporary environment to do some work, you do Helm install, name of thing, do your work, copy your code off, Helm delete, and then it cleans itself up. Everybody's happy. All right, and we'll see more of Helm. Where's my mouse again? Once I get to the live demo. Dang it. Come on. There we go. Live demo time. And like, I really do hope you like YAML, because everything in Kubernetes is YAML based. So you've got YAML files, YAML spacing, YAML things. All right, let me just switch my screen to be a mirroring instead of other mode. Arrangement, mirror. Now, here's hoping that didn't completely catastrophically break the recording. Wow, that's dark. Nope, that's not it. Nope, that's the, sorry. Okay. Are we, okay. Let's just run with it.
Can you zoom a bit?
Yeah, I'm gonna, yeah. Okay. Oh, I guess first sort of side tip. If you're not using VS Code to do your Kubernetes stuff, I'd highly suggest it. The Kubernetes plugin in it is awesome. I actually think it's the official Kubernetes tool at the moment. It lets you see all the state of your cluster. It lets you switch namespaces. It lets you connect to terminals. It lets to do like it does. It's great. So I highly recommend using VS Code. So first things first. Let's just hide this stuff. Okay. Is that legible? Do you want me to zoom in some more? Awkward silence means that we're good. All right. So this is my values.yaml file. So when I run Helm install, I'm going to pass it this list of values, and that's basically just filling in all the arguments that your Helm chart has to actually configure your cluster. So we're going to ignore this global section up at the top here. So the first thing I want to do in my Helm chart that I wrote will be I want to tell it what cluster or what container I want it to use. So in this case, I actually created a copy of the Drupal camp Ottawa, like headless Drupal side, and I create a container for it, and I'm telling it so whenever I deploy to the cluster, I want you to always pull it, because I'm just deploying to this tag, and I don't want to just use a cached copy of the container every time. And because this is a private Docker repository, it has to download the credentials to actually log into Docker and the Docker registry and download things. Okay, so now that I've got the base thing, it's like, wait, that's the container we're going to use. Now let's go and configure all of the parts that we want inside that in that container. So I defined the Drupal file public path, app websites default files. File private path will be app and then private files. And then the web root is going to be at this app web directory. So yeah. And down here, so this is the number of replicas. So by default, so I'm just going to deploy one pod because it's the quickest. And then here's where, Drupal hash salts, whether I want to install Drupal or not. I don't want it to because I have a database there already. The database credentials. So normally these, you wouldn't version them and save them in your YAML file. You'd pass these in as arguments when you're doing the Helm, the Helm install on the command line. So that way you're not versioning passwords. Once again, it's a demo site, so it doesn't really matter. I don't want it to do MariaDB because I didn't have time to do the MariaDB stuff, so we're going to skip over that. Next part, so we want to expose a service. So because this is Drupal, and has a web server, we want port 80 and 443 to be load balanced across whatever pods I've got. I don't really care about defining custom node ports. And then, yeah, external traffic comes in through cluster, ingress. I'm not explicitly defining an ingress thing. This is mostly because this costs extra. Usually when you're dealing with Google Cloud or DigitalOcean or whatever, the ingress bit, basically your external load balancer that allows external traffic to come into your application, you pay, that's where they make you pay for it. So you can deploy usually as many things you want within your pod, but the second you want to expose it to the world, that's when you got to start paying for things. But it also handles things like, getting SSL certificates it uses Let's Encrypt. And then, yeah, just the name of the hosts and things that you want your Drupal site to respond to. Anyways, skip over that. Okay, really persistence off, just for demonstration purposes. Skip over that. Drupal pod file, same thing. Okay, so maybe I'll just talk about the volume claims. So, no, I'll talk about that after. Okay. Resources. All right, so here's where we start. So each one of those pods, when it's running on the nodes, will be allowed to use up to 512 megs of memory, and we'll get 300 Ms of CPU. I don't know what the M stands for. I haven't learned that yet, but it seems like enough. And this is basically how you divvy up your resources available within your entire cluster. So if you have, 7 8 gig, quad core machines, when you're deploying your pods and your replicas, you do the math here, and then that's basically how you optimize your resource allocation. You can always over resource, but that's assuming your other pods are using things. Anyways, don't overtax your clusters. And then liveness probe and readiness probe. So when the deployment's happening, especially when you're running like the Drupal install as part of the deploy, the pod has to be able, or the cluster has to be able to tell when it's actually ready to go. So, the Drupal install, if you're deploying, Drupal minimal, it's usually ready pretty quick. But if you're deploying WXT, for instance, the install can take like 3 or 4 minutes easily. So this is just what it uses to check to see if everything's ready. So if user login reports back as a 200, it's alive. And it's ready to go. It's same thing. Basically, it's ready and it's alive when user login reports back as valid. Metrics we're not dealing with because I didn't do that, and NFS we'll deal with later. Okay, so let's stop talking and start deploying. Just going to refresh that. All right, so this is the current state of my cluster. So I'm using the default namespace, the list of nodes. So these are the physical servers that exist over on DigitalOcean. There's 2 of them. You can see I have Tiller installed as a pod, so that so when I ask Helm to do something, it tells Tiller, hey, deploy this for me. And there's 2 nodes. This workload section is, I left a job. Okay, well anyways. No, delete the job. Yes, please. All right, hopefully that goes away. So endpoints, network, and then storage. So you can see the storage classes. So the only classes available right now are the DigitalOcean block storage, which by default are only support read, write once. So if you ever go look at Kubernetes documentation, they'll talk about like different write modes for disks. So disks can be read, write once. They can be read once somehow. They can be read, write many, which is the one we actually want. So it's essentially like when you mount the disk, this is what what your users are allowed to do with it. So if it's a read-only drive, you can set it to read only, and you can have it limited by 1 pod or as many pods. So read many is actually supported, but read, write many, this guy is not supported by the DO block storage. So this Helm chart is to take care of deploying a storage class, which is the NFS one, that allows multiple pods to write to the same place. Anybody lost before I continue? Anybody bored? A little bit napping? I can't see anybody right now. It's really dark, so it's hard to read the audience when it's dark. Okay. So to install my Helm chart, That's too big now. Okay. So I'm going to do Helm install charts Drupal. And if I look at the files in my local instance here, I have a directory called charts, and I define my Drupal chart. And then there's all the chart stuff in here, which we'll get to in a second. So it's going to, instead of looking at the remote repo where Drupal stable is, it's going to read from my local and then deploy it. So let's go back to the cluster. And this is the part that Luke's been waiting for. Watching my demo crash and burn. Now we wait. Okay, so you can see a deployment started. So there's a DCO demo Drupal deployment happening. There's a pod that's being created that's not ready yet. That's the little red dot in case you didn't know. And then we have no new storage stuff. And Helm releases should refresh in a second. There we go. So we have Helm release called DCO demo. So from Helm's point of view, it's done doing its job. It generated the release, which we'll look at right here. And let's switch you to YAML. Yeah, that's not how you spell YAML. Okay, and this is what I meant by you have to really like YAML and why you want to use Helm charts. Because if you didn't use a Helm chart, you had to write this by hand. I'm still scrolling. There we go. So the Helm chart uses a combination of templates written in Go for some reason. I don't know why. And probably because it's Google. To generate this thing which has the name of the database host, there's the password and stuff like again. All the protocols, all the values that we put into that one tiny YAML file, it took them into consideration, but then generated all of this other stuff to actually make it run in the cluster remotely. So this is why you want to either use a Helm chart or write one to do your deployments, because otherwise every time you want to make a change to something, you got to go into this giant file and then change it. So let's just close that up. Now if we go down here, you'll notice it spit out a big please be patient, Drupal is taking a few minutes to install. Da, 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 da. Please use these things to do stuff. That actually comes from the chart in the templates. There's a notes.txt file. Now, for Kubernetes is the only thing that I'm aware of that actually processes a text file and then executes it, because you can see here it's dynamically filling in host names and things. It's actually being processed. So I'm not a huge fan of them taking a text file and then actually executing it, because then all of a sudden your text file could have security issues. Anyways, but this is essentially when Helm is done spitting stuff out in your chart, you can output information for them to either get started or let them know how to proceed after your chart is installed. So in this case, it's going to print out the Drupal username, the link to it, all that kind of stuff when it's ready. This is pretty much verbatim stolen from stable Drupal that Bitnami wrote. Yeah. So go back here, put that there, and then if I refresh here, so we have a green pod, so that's good. And there's just cron failing. That's fine. That's a known bug. But if we right-click, we can actually go to terminal. And this is one of the reasons I really like the VS Code plugin. So I'm actually connected. It created a proxy connection, and I'm actually on the container now on that pod in the cluster. So if I go to app and I go to web, yay, there's Drupal. Ooh. And if I do address / bin drush status, bam. And to prove to you that it's running, because I can feel the doubt. Okay. Okay, where's the ingress? Dang it. No, that's the database host. Endpoints. Okay, I'm going to do this the lazy way. That's bright. Where's DigitalOcean? Kubernetes. demo, nodes. Here's the load balancer. Come on. No. Not working. Load balancers. Okay. It should be there. Hey, there's the Drupal. No, that's not exciting. All right, fine. Yay, it works for me. All right. So yeah, so there's Drupal running in the cluster. There's no files or images because we just mounted a clean. We are using an existing database with no files, so that's why the images are busted. But this is it's a running instance of Drupal, and so now, if I exit the thing, I can do helm delete -- purge. And then the name of my thing. Then now this will actually go into the cluster and then get rid of that release. So it's going to kill the pods, except maybe the Drush Cron one, because that guy's been a pain in the butt the last day or so. Oh no, got rid of that one. Good job this time. All right. And if I refresh here, we get nothing. It says connecting. So that's proof it actually worked. So, all right. So that's great. So that basically, that functionality is essentially what Drupal stable does. It brings you up a blank Drupal instance that you can do whatever with. But I want replicas. I want all the Drupal on the cloud. So we're going to go back to our values file, which once again, this is using a file. Is just you can set all these arguments using the command line. If I do like helm install -- set and then name a value. That's equivalent to just using this file, so it's just easier to have your arguments in here. So I'm going to go down to replicas. Let's go crazy. I've never actually deployed three.
I thought you'd say like 30 or something.
Okay, well, I mean, I've only got 2 VMs on and they're the cheapest ones on DigitalOcean. So let's plus that's take time to do it. Okay, so. Same thing, helm install, blah, blah, all I've changed is I want 3 replicas. So when this comes up, we should actually see 3 pods. I'm very excited this demo's working. I'm trying not to jump up and down because, yeah. 4 months, all right? This is the most complicated code I've ever written. It's just a bunch of YAML configuration. So, there we go. So Helm finished telling Tiller what to do. Refresh that guy. All right, so we got 2 out of the 3 pods are available. So that's good. And then if we go to the, where is it? To the nodes themselves. So these are the physical servers that exist. We're going to look at the pods that are there. So it decided that DCO demo, one of them goes on this guy, and Drush Cron goes on that guy. And then the other pod takes care of that one, and where's DCO? Where's the other DCO demo? Oh, he's not ready yet. Okay. So as you can see, like I'm not controlling where they go. I guess that's the magic of the cloud. I'm just saying I want 3 of these, and then your Kubernetes cluster takes care of deciding where those resources are best deployed to. Okay. Still waiting. Okay, well, in case. It'll do it eventually. So now let's go look at one of those pods. So I'm going to connect to this pod via the terminal. And I'm going to the /app/private files folder. So as you can see, once I can type, there's a whole lot of nothing in this folder. And if I create a file here, there's a file called here on this pod. If I go to a different pod, hopefully that wasn't the same pod because I don't remember which I clicked on. So I have the same instance of Drupal that is load balanced in my cluster, and I wrote a file to one of the private files, went to the other pod. It does not have that file because the storage that DigitalOcean provides is unique per pod. So that was the main hurdle that we're trying to solve here. So I've got a bunch of replicated Drupals that basically are useless because they don't have a shared thing. So we're going to take these pods down and do, okay, hopefully it doesn't cry foul that I'm trying to delete a pod that wasn't ready. Da, 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 da. Don't you dare. That's right. Okay. So pods are gone. Things have been reset again. Great. That's the other thing that's really nice about Helm. You can test, well, like in theory, that was a three node load balance cluster of Drupal sites that we just like brought up and took down, with one command. So, and you're testing things, you're iterating. It's really fast to bring up a lot of really complicated sort of setups once you get your Helm charts in order. So we're gonna go back to our YAML file here. Just gonna shrink this back down. So here's where I'm going to turn on the persistence. So for anybody who doesn't know what persistence means, so when you're bringing up pods, they're designed to exist and then be destroyed as needed. But that can cause problems if you have something like, if users uploaded an image, you don't want the image to disappear if that pod decides it has to be like recycled for some reason. So persistent storage is storage that persists pods being destroyed. And in DigitalOcean's case, they create a block storage pod, and then I'm asking for 100 gigs. So this is also one of those things if you're playing with Kubernetes that you're gonna have to pay for storage typically. So start with small amounts and then work your way up. In this case, 100 gigs isn't that big a deal. But so what this is going to do is it's going to create an NFS pod that will allow the other machines to make a persistent volume claim against it and then ask for storage. And I'm going to ask for 50 gigs for my Drupal public files, and the private folder is also going to get 50 gigs. So the total size of the persistent disk that I'm asking for is 100. And then I'm going to divvy up 50 for each. So that way I can grow it up or down or run multiple instances. So, I need to turn this on down here. Almost broke my demo. And this is the important bit, the actual. So this is using the NFS server provisioner. So it's a separate Helm chart. So he's creating a read write once pod that has the DO block storage of 200 gigs total. These are the mount options for NFS. Some of these options are optimized for Drupal. Save that. And so it'll get created along with the volume claims for Drupal, and then we should have a shared disk 3-node cluster of Drupal sites. Okay. Come on. Return non-bool value.
I think you said it.
I wrote ter instead of true or something.
I think you wrote enable on it.
Ah. Stop it. True. Screwed up my own demo. Okay, all right. Well, it's trying to do it anyways. So that's really not going to work. Dang it. So let's try deleting it and hoping it actually gets rid of the persistent storage. Because that's the thing about the persistent storage, it's designed to persist. So sometimes even when you ask DigitalOcean, hey, can you delete this for me? It goes and checks, see, am I supposed to delete this? No? Okay, well, I'm just gonna leave it there then. Come on. Can't believe I screwed up the finale. Damn it. All right. Oh, geez, it's already 1:45. I'm supposed to be done now, I think, right? Oh, crap. Okay. Ta-da. Hold on. Let's see if I can actually get it to do it. Okay. So let's just go Damn it, I thought it was going to be short on time. Okay, well, while that's trying to delete, I'm just going to show you some of the templates in here. So this is my Helm chart itself, so it's called Drupal. It has a subfolder called charts where you're supposed to actually store the copies of the external charts that you're using. I don't know why they designed it that way. So the templates, so the biggest one is this deployment chart. So this is the one that generates that giant YAML file that we looked at originally. So you can actually see it's grabbing values from the other YAML things. It sets a bunch of environment variables so that Drupal can actually talk to the database. Sets up the port. So you basically write this template once, and then you can reuse it a whole bunch of times. I mean, that's how like a package manager sort of works. And then you can do other things. So I have the list of claims that I need. So these are all the volume claims predefined, so that you can reuse them. So I have a persistent volume that if I have it enabled, it'll actually ask and generate something with that unique name. So for cron, so this one of the big ones that the other charts didn't handle was actually executing cron. So Kubernetes has the concept of cron jobs within the cluster. So it'll bring up a pod, run the cron task, and then destroy the pod as required. So this one brings up the same container as the one that I deployed, and then it runs drush cron in verbose mode to execute cron, and then it'll retry if it fails. So the bug I'm working on right now is for some reason drush is saying cron command not found. I'm like, really? So that's what that does. And jobs, so this is the other thing that the other ones don't do. So when Helm runs, it has the concept of hooks. So when something is about to be deployed, or after it gets deployed, or installed, or updated, you can actually, this actually runs like drush updb, creates backups, it does your drush, your config import command. So it takes care of doing all of the Drupal-y stuff that you have to do every time you do a deployment, but it does it for you automatically by bringing up a container and then running those executions for you. So that way it's all automatically managed. So all you have to do is a Helm install, tell it what the name is, throw it to the cluster, and then all of those things happen automatically. You can even do stuff like a pre-install or pre-update check that, let's say, dumps the database to like an external storage, so you can do a restore. And then you have stuff like rollbacks where, let's say you automatically generated that backup. You could have let's say you want to roll back a release, something failed, you could actually have it automatically grab that database backup and restore it, because those are important things when you're rolling back a Drupal deployment. So all these conveniences that the other charts don't really take care of, I want to build into this thing, so all you have to do is run the one command and everything is taken care of for you. Okay, well, you know what? Let's do this. Give me 1 second. Helm install Drupal demo 1. Let's create a second release with additional storage, with stuff going. Anyways, while that's running, because this takes actually a minute or two, any questions that anybody has? I don't even know how to turn the lights back on. It's like a heater. Oh no, that's a spot. That's what okay. They're not labeled, just so you're. There we go. Okay. All right. Are there any questions before, or is everyone thoroughly, completely confused and be like, what the hell was that? Okay, one question there.
Helm Charts available anywhere?
Pardon?
Are you making your Helm Charts available?
Yes. Once I clean out all the parts that are hard-coded for this demo. And cron works. Yeah. But yes, I'm going to put them on. I'll be on GitLab.com or on GitHub, one of the two. I'll just put them there. Yes?
Was it challenging to make your MySQL or like your database persistent?
No, because I'm using an external cluster that that I already set up. So this chart doesn't take care of setting up the MariaDB cluster. There's already a MariaDB module, and it does it super well. So
multiple pods writing.
yeah, it'll generate the databases. It'll generate the usernames and passwords. It does all that stuff for you. I just didn't want to add complication to me writing a Helm chart, also having to write the parts that make the database part go. So I used we wrote a tool called Drop for it, and it generates MariaDB clusters automatically with Puppet. So I just used that guy for this time. But yeah, but you can run your database in a cluster. Just be careful. Make sure you're using like persistent storage, because if your pod disappears, your database goes away like completely. So be sure to use that. Yeah.
So you use one container, if I followed correctly, to database PHP and Apache?
No, it's just PHP, Apache, and Drupal. Yeah, the database is a separate thing. Yeah.
Is there any reason why PHP and Apache are the same container and not on?
So I decided I want to architect it that way because if I change the web server or I change PHP at all, I have to change Drupal. So anytime I deploy something, if I want to upgrade Apache, I'm gonna have to do something to Drupal. Or if I'm gonna have to change a version of PHP, so I treat them all as one binary that gives me a Drupal site. So, and conceivably I could even just use the SQLite storage on the thing if I wanted to actually just run an instance of Drupal without any database backend at all. So that's why I have them as one thing, because they're all very, very related to actually making it function. So, yes?
Quick question, is there anything that's like specific for DigitalOcean, or do you feel like that could be?
The only thing that's specific is the class for asking for the block storage. So normally you should be able to just put the word default in there, and then it'll just pick whatever one it has. So if it's Amazon, it'll use S3. If it's Azure, it'll use their whatever Azure has. But yeah, everything else should be just run it, and then it runs on there. Somebody else had a hand. Yep.
How confident are you with this Helm Charter going to production?
This one right now in its state,
No, like after finishing.
it should be. I am going to run it in production. Yeah, because like for us, like at Coalfront, we have about 80 machines that we manage through a Puppet Master, and I'd say probably about 30 of them are just dev boxes that are just in there idle most of the time. So what I want to be able to do is have my developers just bring up an instance in the cluster, do the development work, and have it and disappear, so that I can save on some hosting costs that way. So and I do plan on deploying like Drupal Camp Ottawa's site on a cluster too, just for fun. So yes, the goal is to make this 100% production ready, so that we can use it professionally and other people can use it too. Any other questions? Dave's here now, so that's good. Yeah.
Oh, so he can answer all of them.
Yeah. Yeah.
You
Yeah.
saved all your hard questions for me?
No, well, I didn't even bring up the part about the Helm cube config lying to us. So, yeah. Yeah, be sure you're using the latest version of everything, because I know the Kubernetes says on version 1.16, but for anybody who's running Kubernetes, version 1.14 to 1.15 to 1.16 has like breaking changes left and right. Same thing with Helm. So make sure you use the latest of everything, because this is very much a new technology that you want to use the latest of whatever it is. All right. Well, thank you for listening. Yeah. There. Okay. There's proof. It deployed it.
You made it not confusing.
How'd the live demos go? You had a lot of live demos.
I deployed 3 things and I screwed up I typed in the word enable instead of true. It was a Boolean.
Oh no.
Yeah. App, private files, touch,
Doesn't matter how like
here.
debugging Kubernetes issues.
If I exit and I go to a different pod, terminal, see, app. Yay, see, multiple pods reading the same here file. Yay. There you go. I have proof on video. It worked.
Congratulations.
Thank you. All right, let's stop that recording.
Now we're going to stop.
Yeah, no problem.